Okay, so in this tutorial we're going to solve this question, which is saying a projectile is launched with an initial speed of 60 meters per second at an angle of 30 degrees above the horizontal. The projectile lands at the hillside later after 4 seconds. So just this, we read and understand first step. So doing that, we are going to draw or to write down the data given. Let me use my mouse. The data given. So data always go by this, so for this displacement we have x final minus x initial there, and this y final, because it is kinematics in 2 dimension, y initial this, so the displacement equals this, which is just the change in x and the change in what, y. So this is what you should write first. You write x final, you write x initial, you write y final, you write y initial, like that. Then you come to the u. This u means initial velocity. Initial. So initial velocity, you also identify the components. We've got the initial velocity in x and the initial velocity in y. You're right, it's 2 dimension, y and x axis. So vox, you also write voy, like that. Okay, we are understanding the question. Then we come to the final velocity. This v is final. Also the final has got components, v final in the x direction and the v final in the y direction. So you write these two, v final x, v final y, like that. Then you come to the a. This a in your SUVAT stands for acceleration. Then this is acceleration due to gravity, which is equal to g, and this g is equal to 9.8 meters per second squared. So when you do that, you write this g there down, say g, like that, g. And if you do that, you come to the time. Time is just t, you write t. So in this case, your x final, remember what we said? We said this x final equals the range of the projectile. So this is the range. Then in this case, it is, we draw now our projectile. Drawing that, it will look something like this. I'll draw it here. This is our horizontal. This is x0. Then this is our x final. So imagine there is an hill there, a hill there. This is the hill they are talking about. Then a projectile is set at this angle, which is 30 degrees. Then the velocity is 60 here meters per second. So this is the v initial. Okay, so like this. Then it went like this. Then it's saying, so here, imagine, just take note of this, there is always this height at the maximum point, and this height is the one we are calling, because this will be our y final, and this is our y initial. So our y final is always equal to the height of the projectile at the highest point from the horizontal. Then y initial is, in this case, is 0. Even the x initial in this case is 0. You can see x initial is just 0 here. Then the distance between this and this distance here is the one we call the r, the range. See? Then it's now time to resolve this initial velocity. So I'll take down that, I write it here. This initial velocity has got a magnitude of 60. Then it has components, meaning it has got this Vox and the component in the y, which is Voy. These are initial velocities. Don't make a mistake of dealing with this. This has got components. Then this is theta. So from this triangle, you can tell that Voy is equal to, because it's in the opposite with the theta, it is V initial sine theta. Then this will equal 60 sine 30. So before you do anything, always fill up this data. At least you write the unknown, the knowns, and you leave out the unknowns so that you start solving for the unknowns. So doing this, we'll find this sine 60 sine 30. It's just 30. So this is equal to 30 meters per second. This is our Voy. So we come to the Vox. Solving for Vox, it will be V naught, because this is adjacent to the theta, so we use cosine. You say cosine theta. When you do that, you substitute. This will be 60 cosine 30. When you punch that on your calculator, you're going to have something like this: 60 cos 30, which is just 51.96 meters per second. So take note of these two, the initial velocities. You even write them here. So Voy is 30 meters per second. Then Vox is 51.96 meters per second. Then V final x, just write this, because we said the velocity in the x direction is always constant at any point, meaning V final x is equal to V or x. It's always constant. Take note of this. They might come in the conceptual questions, multiple choice. Always take note of what I'm explaining. You will never find them in the lecture slide, but they might assess you on that. So this is just Vox, meaning this is just this 159 or 51.96 meters per second. Then V final differs at point, so just put a question mark on V final, because they might ask you V final at this point, V final at this point, V final at that, V final at that. It differs in the y direction. Then your acceleration, since the first projectile is set against this, so your g will be negative 9.8. Always take note, if it is set going towards the gravitational force, it's positive. Then if it is set going against the gravitational force, it's negative 9.8 meters per second squared. Then the time from this to there, it is saying 4 seconds, meaning this part is 2 seconds and this part is what? 2 seconds. From here to there 2, from there to there 2, meaning 4 seconds. The projectile lands at the hillside after 4 seconds, meaning it took 4 seconds to reach there, meaning half of this should be 2 and half of it should be 2, meaning 2 seconds t1, which is this, and t2 is equal to 2 seconds, t2 is this. Then from there you write the total time. Total time is just what? 4 seconds. So it means we've grouped our data. We can now solve the questions. You can see this is filled up except the final y, which is the unknown. So we can now go to the solvings. Let me just rub this part. We solve for the question now. It's very important to analyze your data like this. Okay, so we can now proceed. We answer question A. A is saying what is the velocity at the highest point, and here this highest point v final y is always what? 0. So this is a direct question. Just say A is equal to this A, answering this, say v final at y max is equal to 0 meters per second. You are done with this. This is the velocity at the highest point. Then what is the straight line distance from the trajectory? So straight line distance, it can either be this and this. So we can calculate for these two. So we say height. For height, you use this formula. V squared is equal to initial squared minus 2as. Then you compute this is in the y-axis, meaning in the y-axis that v final should be v final y from here to there, then squared, then v initial in the y. So this is where these two comes to work. You don't use this system, you use its components because you are specifying the axis. Then 2, the acceleration, you are using a g like this. Then the displacement here, x final, it is just h. It's the one we are looking for. Say h. And this is 0, v final. So 0 squared is equal to v initial y, which is 30 squared minus 2. Then the gravitation, so here is plus 2as. So here is plus, plus. Then this, when you use negative, it means you've already assumed that this g is negative since you are going the opposite. So I want you to know where this came from. Minus 2as. But in the actual sense, it should be plus. But regarding the negative acceleration, because you are going against it, this is like this, 9.8. Then you have your h like that. Then from there, this is 0 is equal to 30 squared. It's just 900. Let me rub. It's just 900 minus 19.6 h. You've seen that this minus has come. It is this one. So this is where it comes from. But in the actual sense, it's like this. Okay, if there is plus there, but when you consider this to be negative, this will turn out to be like this. If your projectile is going like this, this will remain like this. So this will be negative 900 is equal to negative 19.6 h. Then you do your algebra there, 0.6, then h is equal to 45.92 meters per second. Oh no, not per second, meters. I'm now used to the velocity. Let me wrap this. It is meters because the height. Sorry. All right. So this is your answer, height. But you have to calculate for the range as well, because these are straight line distances. This is the straight line and this is the straight line. So calculate for this and also calculate for this. So calculating for this, we are going to use this formula to say s, which is displacement, is equal to initial velocity times t minus half, so plus, not minus, plus half a t squared, like this. So let me use a different color. I just demarcate this. Okay, so from this, since this we are dealing with the x-axis, this displacement we are looking for is what we are calling r, is equal to this initial velocity, should be the initial velocity in the x-axis, times the time plus half g as the acceleration for gravity times time squared. Now in this, remember we said if velocity is constant, acceleration is equal to 0. If velocity is equal to 0, acceleration is equal to constant. So these two, have you seen this part? velocity is equal to 0, the acceleration remains constant, which is 9.8. No wonder you use this always, because velocity there is equal to 0 at this point. It's constant. Now, in the case where you've got the velocity to be constant, acceleration is 0, meaning in the x-axis acceleration is 0, because v initial is equal to v final x. The velocity is constant, meaning acceleration is equal to 0. So where there is g there, when you put this 0 there, here, when you put a 0, g squared, this formula will come out to be like this: r is equal to v initial in the x direction times t only, because this part will be automatically what? 0. Then if you compute your r now, you put your v initial is 51.96 in the x direction times the time, which is equal to 4 seconds. So 51.96 by 4. When you compute that on your calculator, you'll find that the range is equal to 207.84 meters. I'm sorry. It landed. I thought it landed on the other side of the hill, but in this case, the question was saying it landed at the side, not on the other side. So the same way in that question, I did something like this. We drew that. It was like this. We did this, and for sure, having done this, we found what our r was. This was our r. Then even the height, we found it. This height, we know this. Even though, so let me just show you. We found all these things. We found them. This was the initial velocity. We found everything here. Yeah, we found all these things. That's from here. So I'll be showing you so that you are not confused. So in this case, the projectile was saying it was something like this. So this is the hillside. So consider this to be the hill. So before reaching, so this is the hill we are talking about. So before sliding here to complete this, okay, say this hill. So this is our r. This is the r we are talking about. So that you're not confused, let me use a different. Let me do this first. Right. So this is the horizontal. Then this from there to there is the height which we found there. We solved it. It's this one. I show you. It's failing. I don't know what's happening. Okay. This is the height. This height. This here, h. It is the one we found using this formula. This one. It's the h there. We found it. So it is just one and the same with this h. Nothing has changed. Now in this case, there is now, this is the straight line distance, because this is the height and this is the range. They could have specified if they wanted us to solve for the range. In that case, we solved for the range. So this distance is the one we are looking for. This. Okay. Then from here to there, time is just what? 4 seconds, like that. So we want this distance now. This d. So solving for that, we first have to find this comma small h here. This small h. So doing that, we are going to solve for that because it's from here to there. So we'll do this. We'll use this formula. S is equal to ut plus half at squared. So this we can substitute here. We put x or y, which is in this case the h. I just write small h is equal to v initial in the y times the time taken plus half g, which is equal to minus 9.8. Then t is just 4 squared. So even here I put the values. So in this case, the y we found, y initial Y initial is this. I show you. So Y initial is 30. So we're going to put 30 where there is Y initial. So this is 30. Then time is 4 plus half negative 9.8 by 4 squared. So when you solve this, this will give us 120 here, and 4 squared is 16 by 9.8 divided by 2. So this is equal to negative 78.4. When you do that, this is going to give us minus 120. This is going to give us 41.6 meters. So this is now our h. This h here. So doing that, we can now use our triangle or Pythagoras theorem. Yeah, Pythagorean theorem, where this will be our d, the one we are looking for. Then height we know is 4.16, like that. Then this is the range we found it, which was 207 point. Let me check my calculations there. Okay, so the range somewhere here. Yes, the range we found it to be this part. What is it? 51.96 by 4. Yeah, 207.84. So it's 207.84. We can now use this. D squared is equal to r squared plus h squared, because this is equal to your h and this is equal to your r, the range. We're now finding this distance here. Then doing that, this d will equal this r, which is 207.84 squared plus 41.6 squared. Your distance is now this. The distance is equal to 211.96 meters. So this is your answer, the one expected. And like what we did this side here, we just solved for the range and the height. But to complete this question, this should be the answer. You consider this solving here, because I thought it was landing on the other side of the hill, but it said at the side of the hill. So before the hill is done, it landed somewhere here. No wonder we considered this and this small h there to find this distance. No wonder we are having this. I hope it's clear.